Hello, everybody. My name is Seelan Manawalan. I lead the product management for Aruba's software portfolios, some of the cloud software products, including Aruba Central. And with me is Jose Telado. He's our chief data scientist, and he's also HPE fellow and VP of engineering for Aruba. He's kind of instrumental in building all the AI stuff that we have in Central. So with this, I would like to get started. So I know we actually introduced Aruba Central Next Gen last year. We had a kind of a early peak to you last year, and it's good to be back again. So today we're going to talk about a few things that we have updated since last year. We've done tons of new dev stuff that went into over the last 12 months. I'm not sure how much we can cover, but I'll try to do justice to the time. We got about 60 minutes, and we have plenty of stuff to cover. So a little bit, I'll try to go really at brisk pace, and I'll try to manage time for the Q&A as well. Today, I'm going to kind of talk a little bit more about where we are. We start with Aruba Central, where we are today. So last time we came in, we actually showed you a little bit about where we are in the business, how are we doing. We are, again, just for those of you who are seeing us for the first time, Aruba Central is our one platform, go-to platform for taking care of all of the Aruba's infrastructure, network management software. It is cloud native. It's run on a few hundred microservices. It is AI powered. It manages everything wired, wireless, and SD-WAN for Aruba. But let's just give the stats on how are we doing today. So we have, as of last month, we have about 4.3 plus million devices that are managed by Aruba Central worldwide. We have about 1.5 billion endpoint clients that are managed by Central across 30 plus industry verticals and 190,000 plus customers. So this number kind of gives you a sense of where we were last year. So we've grown almost 50% over the last 1 year in an environment which is not exactly conducive to growth, but we've done phenomenally well this year. But what this data tells you is, as we mentioned last time, we have a single data lake where we actually have all of these data for different telemetry. And that is what makes our AI special, because we have really a very rich set of data, which helps us build something very, very useful. But I want to kind of take a step back and give you a peek into some of the thoughts and the vision that we had for Central, and what do we want to actually goal for ourselves. We believe that, yes, we have the telemetry. We have a very rich telemetry, probably one of the richest in the industry when we stream out from the devices into the cloud. But more importantly, what we have is the data. It's a very, very rich data, and we store that in a graph database. And this actually comes with some of these things that we really recognized fundamentally to how, as a network management software, what are the key things that we look at to solve problems for our customers. It's about the clients coming into the network. They have all these kind of things, auth issues, getting in connectivity, looking at network. How are they getting the network addresses? How are they connecting to the applications? What's the experience on the traffic in infrastructures? And not only that, we also look at all the different events that are streamed out by different devices that fall in the path of these traffic. We look at how the applications are solved. Eventually, all this lands up in, like, if you take a typical enterprise, which is about 100,000 clients, give or take some, we're looking at something like 1 million events that actually get shipped to the cloud. And if you're looking at so much of data that just comes in, this is a lot of data, and we are trying to triangulate a lot of events and trying to do slicing and dicing of these data to kind of make sense of it and make it more presentable to the users. Our goal is to basically build dynamic correlations between different data sets. And what we realized is, over the period of time, like traditional NMS that we've seen all over the time, is like you have a bunch of time series where what data are to be stored. We put those data in a particular order, and everybody could just go back in time. We realized that sometimes it doesn't work well for things like states. States are very dynamic. It changes. So we need to keep a lot of correlations between changing states. So we realized that the best technologies that came up that we can represent in network management is using graph. So we kind of standardized a big chunk of our data stores and manipulations using graph database. We use GraphQL, we use graph APIs. It's very powerful because that's one of the most efficient ways to draw multiple data sets together, and especially when we're looking at over a period of time. So you have a whole bunch of time sets of data, and then you cross-correlate. So this is how our foundation is built in the next generation central. So everything starts on a graph database. And of course, and then everything else are like what we do in our central. Our fundamental goal is we want to do all the slicing and dicing with all this data and make it more presentable to the customers. And this is where, what makes sense for users is like, okay, what can I bring in over the last 30 minutes if I have a client that experiences connectivity issues? What are things that can go wrong? What are things that the network sends as telemetry? We're trying to bring all of these data sets together in a single pane. So that's the biggest goal that we have. We also kind of build around it and say, okay, we want to kind of build better AI, which makes more actionable insights. We want to, our goal is to get the best-in-class client experience. We really believe in actually discovering as much as possible the DNA of the client, if you will, the endpoints. So we have profiling built in, classification built in. We do machine learning based on the behavior. We try to figure out what the client is trying to do, what are their experiences in terms of what the flows look like. But also we're looking from the application side. We built quite a few new things in application as well. So I'll be taking you through some of those things in the next few minutes. But this is essentially where we are innovating a lot. And this is something that we want to kind of talk about more. But I'll start with something which is more fundamentally a game changer for us. And this is, you'll see a lot of innovations, but this is the first of one that I want to touch upon today. Is we now have, last year when we released New Central, we had all the monitoring reporting stuff shipped out. We have now about 320 customers in production running the next generation central. We have about 300,000 devices that we manage today. So this is in select availability. We haven't thrown it open to the public. General availability, it's just because we want to kind of bake it a bit, and we are waiting for the configuration to come on board. So now, last month, we actually started shipping our configurations. And this configuration is special because this is actually kind of something what we have been building over 40 years of HPE's history, where we have actually built configurations on 4 different operating systems, different types of CLIs. We actually taken all of these and built a common configuration model. It's kind of unique in industry because we realize a lot of our customers are talking about automation. They're talking about, okay, I want to kind of more have a simplified way of automating at a mass scale. And the best way to do it is instead of doing multiple different API sets, you have a common data model which can expose one API set, and that's how you automate with single set of APIs for all device types.
So if I'm looking at this picture correctly, device group X gives me the option of some more flexibility underneath the site hierarchy, which you couldn't have before.
Oh yeah, so let me explain this further. So today what you have in Classic Central is a 2-level where you have a group and a set of devices. So it's like a 2 levels. And think of this device group as kind of very much equivalent of what is there today. Now, we also have a lot of our campus EOS 8 customers who are used to building much more linear hierarchies in the mobility conductor, and we have both these worlds coming together in CNX. So what we did was we realized that there are, it's like you can't have one hat fit 2 heads, and that's the problem. We have customers who are very simple mid-market customers who look for easy button configuration, block configuration, and then we have these universities and the big enterprises who need all these big complex configuration set, and we're trying to balance between the two. So what we came up with is a multiple hierarchical configuration model. So you can do one 4-level on the left that you see on the red circle, and then the green circle where you can also juxtapose a device group. So this is pretty interesting, and one of the use cases that you could think of is like, I have a demo that I want to kind of spend more time on. But if you were to simply think of this, like we have a lot of big enterprises who have different sites in different geographies, and these geographies have different site collections, but they also have some SSIDs that they want to go flat across all locations. So when you do that, then you can have a device group that can actually push some SSIDs across all locations, which is flat, and then the rest can be on a site and a site collection basis. So that kind of gives you a lot of flexibility in how you can configure. This kind of brings in both the capabilities we had in our mobility conductor plus whatever we had in the classic central together. So I think it's easier for me to show the demo. So I'm going to kind of like spend most of my time now trying to show you a live demo. Now this is our internal test cluster. This is the new central, and I have two setups. This is where we end up, and we built something what is called the knock view. Last year, you probably would have seen just one site and a lot of those placeholders for the blocks. We kind of filled up a lot of these over the last few months. Now, in this, when you go into the configuration model, now this is how our configuration looks like. So this is essentially, we have a concept of library now. And we realize this is one of the key asks that our customers were looking for, where they want to pre-stage configurations where the devices are not there, and they want to actually put those configurations in. We actually have now got a concept called library. It's basically a repository of all the configurations. These configurations are all stored as profiles, and these profiles are then stored in the library. And these configurations then get inherited across the sites. So if, for example, you have global, site collection, site, device. So these are 4 levels of hierarchy that I showed you in the picture, and then you have this device group which kind of cuts across horizontally. Now, the beauty of this is like we build it once. The config model, the APIs that we expose are auto-generated because these are Yang models. We have common configuration. So everything is API first. So the moment we finish building the configuration, the API is already exposed. And then we use that same thing to build these UI cards. So the UI comes second and the API comes first. So just a quick glimpse of that is like if you look at these, this is our Swagger. For this are auto-generated. We have all our APIs listed here. The reason I picked up VLAN is I wanted to show you something which is like a common configuration. What you would notice is I just have one API which says layer 2 VLAN. I scroll down here. I go over these payload. You'll notice these payloads have got very common constructs, like you have static configurations. You're looking at the interface configurations. You're looking at some of these basic forwarding mechanics for the VLANs. You have multicast add-ons for the VLANs. Notice here, it's a very single unified configuration for VLAN. It doesn't tell you I'm pushing this for an AP, a switch, or a gateway. You have a common API. So imagine the power of running an automation that you just have a single API call for the VLAN, and you can push it to all the devices if you want. Or if you want to filter it down, you have like a device function, which you can choose the device string and actually choose to send it only to a few of these devices. So this is the power of this common configuration model. We actually are seeing a very good response initial response from customers have been really, really exciting. So this is the API version of it, but if you want to swipe back, this is the UI, and this is the same VLAN that you see. So in this case, now you define a VLAN. It says there are 10 profiles, so you can create multiple profiles, and it tells you these are library profiles, so these can be shared across the hierarchy. But then you can go inside a site, the same VLAN that you had, you can go inside a site. So I'm just going to pick one of these sites. Let me just take, let's say this one. I'm just going to take a guess on this one. So let me just take SJCCP. I don't know what this is. So, okay, this is a not so great site. So maybe I'll pick one that has more. And I go into maybe the ET Teams one. So yeah, I have a VLAN here. Now you can see this VLAN. So it has got only one of the VLANs that was plumbed in the library. So you can actually scope the VLAN specific to a particular hierarchical level, and you can override that at every hierarchy. Now it tells you that this is inheriting from the global. Now the same way you can go back and you can look at other ones which are kind of more prominent. Like for example, I'm just going to pick up this one, seems to have a lot of devices. There's again one VLAN. But it kind of gives you an idea of, you can create VLANs at the library level, inherit down the hierarchy, or you can also create local profiles. If you are creating a local profile, then say, for example, I just pick something, this seems to have 3 VLANs. Now, you could actually have, this is like a global scope. You configured this in global, and then you're inheriting down to the site and down. But here you're actually going in the site level and you're overriding this config in one level below in the site. So you give you option of, and you also notice there's a pin. This pin is the concept of a local profile. Now this is very powerful construct as in sense that you could choose to do profiles which is globally applicable from a library, or for example, like when you have core routers or WAN edge, you have only very specific configurations. You don't have to kind of make it available to any broader set of configurations. You can do a local. So that's the difference that you see. You have the share, which is essentially inheriting down, and you have this pin, which is essentially local to that. But anyway, so this is a lot of stuff in the configuration. I know I've got a lot to show, so I'm going to kind of switch the gear here and go back to this configuration models. I want to talk about the monitoring stuff that we built in the last few months. So one of the things that we've done a lot of innovations is in the applications and measuring application performance in Central. We actually had a lot more stuff come in the last few months where we believe, measuring applications is a bit tricky. It's no one particular measure is comprehensive. As some of the vendors say we do Teams integration, Zoom integration, but that's more like a composite score of a client traffic. It comes out only after your Teams call is over or a Zoom call is over. It doesn't give you the entire picture of what happens during the 1 hour of a Teams call when you go up and down in the traffic. And if there is a fluctuation, how does it look then? And these are things that we believe sometimes the client sees something differently. So we are looking at a strategy where we will triangulate these information from 3 different sources. So we have a UXI agent that we announced last year. You'll see something that now in production going this month and next month. It measures the performances from the client side. We also are building the server side connections. But the most important thing that we have done is historically that's been our strength is we have deep packet inspection in all our devices, AP switches, gateways. We pull telemetry in. We actually look at metrics from within the device and we measure them in Central and actually calibrate them. So we kind of believe in the best way to kind of find out what the application performance looks like is by kind of taking all the 3 data in. Now let me show you something in what it looks like. So I'm going to just flip into something very quick. I'm going to go into one of the sites and show you how this looks like. So this is an example of how applications look in the new Central. So we actually classify more than 4,000 plus applications in the network based on our DPI. We not only do classifications based on our DPI, but we also can do web classifications on how those applications can traverse through based on their destination servers. In terms of these, this is the fun thing that you see here, is we have a column called experience. This is how we measure performance of applications. So you see these applications, and this is where it gets interesting. We are not only showing you data for, how is the network seeing the performance of that application, and also what is the security for it. So we're kind of correlating 2 different aspects in one window. We're looking at the security aspect and the performance aspect and kind of putting in one frame. The other thing that we actually heard a lot from our customers is about, we had this common phrase saying, hey, give me IP fix for or net flows. I want to find the top 10 talkers. And what we realized is that's not the most effective way of looking at the network. In the classic, we used to do these applications, but we never did the slicing and dicing that was actually required for a lot of these. So what we now have is something that we can actually go inside specific application. We can look at what's going on in these. So for example, I'm just going to pick up Teams just for my references. You can click on this application and it actually gives you slices of all the users in the network that are consuming this application. And it kind of tells you what their health is, the client health, how are they connected. They can be wired, they can be wireless. We tell you the slicing and dicing on what WLAN they're connected on, what is the role, when was the last connection, and things like that, which are, yes.
So there's a lot of data here that we can look at, and we're seeing that the client has a bad or a poor user experience, and we got a list of clients with a poor user experience. Could you give us some example what the actual insight is that's driving the poor experience? Can we see that in Central?
Oh, sure. So you're looking at the question is about show the experience of how are you calculating the experience of what the client is.
So given they're having a bad experience,
Yes.
What's causing that? How do I fix it?
Okay, yeah. So there's a couple of things that we have. Let me go back on some of these, and there's so for example, if I go back here and I close this, and I can go inside the trends. Now, if I go inside the trends, I actually see, the rough timelines of what my applications looks like. But when I go inside a specific one, let's take, for example, Teams, right? So I had Teams here. I was kind of trying to get to Teams. Now, when I click here, this is what we measure latencies. Now, if you see the latencies on the left, this is, of course, we created this error in the lab to kind of show you this. But we measure the latencies for the entire hop of the network all the way to the application CDN. And we are actually trying to find out what part of it is in the LAN component and what part of it is in the WAN component. So you see these latencies, we measure these latencies, and in this plot you see that there's a total latency of 828 milliseconds, of which only 7.5 milliseconds were in the LAN component. So this is one of the most common asks, hey, from our network engineers, hey, tell network is not the problem here, right? So we have these kind of measurements that we actually can separate out between what's the latency of the LAN side versus the WAN side. So that's number one metric for your question, right? So that's how we say, okay, is there a network that's the problem, or it's outside of the network in case of this? The other thing that I would like to talk about is we have what is called the insights here. And these insights go into a little bit more on the performance analytics. Now, the other one was real time. It's literally plotting every 30 seconds on the clients how it's moving out. But this one is a long-term application flows. So it's kind of aggregating and giving you a view of what's going on here. It tells you how many flows are there which are looking like good latencies or poor latencies. And when you go inside, for example, it's telling you, now this is beauty. It's not just any real-time application. It's also any other SaaS application, right? For example, this is Adobe. Adobe is incurring latencies over this period of time. It tells you, these are Atlassian. Similarly, you can go over even look at the real-time applications, something like these. You can go and see real-time. You have Microsoft Teams, Slack, Skype. These are measured, but what you're asking is this. When you go into the view, we also talk about, okay, what other reasons could be attributed to why the application performance was poor. So in this case, for the Skype and the Slack, we actually inferred based on the components of our derivatives that there's a lot of machine learning stuff that Jose can kind of dwell in later. And we just, in interest of time, I was kind of steering this faster. But this, you see the top two, it tells you clearly that, hey, this is more like a gateway WAN latency. Whereas the last one, the Microsoft team, is more like an application server side. So we think the WAN latency was not the issue, but from the fetch, we actually realized we do baselining and see, okay, different points. Was it just a WAN latency difference, or it's like the application side, server side issue that actually caused the problem? So we give you that kind of a hint today in the system. Yes.
So just further on what Troy said. So that root cause is telling you something's slow, or something's, and if it said like the Wi-Fi was slow, could it then further break that down as to why?
Yes, in this particular case, you're right. If Wi-Fi was the contributor, we would probably have something else triggering that, and that will root cause into, when we triage it, it'll actually lead into some specific event that would have triggered that. I don't have that one for this one, but probably I could show you some other alert. Maybe we have some example, we can definitely talk about it. I think I'm like 25 minutes in, so let me go. I have a lot of stuff. I had 10 things to show, but I'm thinking I'll probably try to cover at least 4 or 5 of them today. So this is the application performance measurements, right? So the other thing that I wanted to talk about is, okay, we did application performance measurement. The other thing that we are very, very strong in, and this is where is another unique differentiator for us, is how we look at clients. We discover all the clients that are there in the network. We classify them. And this has all been there for many years. We showed you a lot of stuff last year. But what we have now over the last 12 months is we build more capabilities on the NDR. We look at the behavior of the flows, and we are able to actually give you specific threat metrics of what those flows look like and what are the threat vectors for those kind of flows. Besides that, we also are going to be talking about enforcement. Now, there are a few things that I don't want to touch because we are going to announce and show you something live on stage tomorrow. So I just want to keep a little bit of a suspense for those. But this is our client insight capabilities. This again runs a lot of our machine learning. But the goal here is for us to give our customers a single pane for detecting and classifying and giving them full control over what their client performance looks like. So I'm going to kind of click on this one, go into client. So for example, this is our unified client list. If you're in a site, it can give you the list of all of the clients that are in the network. But more importantly, we have these trends. We can plot the trends. Now, if you notice these trends, these are machine generated, where you have this classification for IoT based on the behavior. So you see this symbol, these are IoT classified by machines. And we give you, okay, what's the classification types? We're telling you these are the vendors that are in the network. These are the operating systems that it's running. But more interesting for a lot of our customers, we had one customer who said they had a bunch of MacBooks that was creating some problems in their Wi-Fi network. And you could never know what exactly was going on there. So this is a thing that they actually start looking at, okay, you want to slice the data and say, okay, what is the split of these? How many networks is it working on? So we have a slice and dice of each of these on what networks it's working on, how many VLANs are these clients on, what is the roles that is assigned to. More importantly, we're also showing what are the downloads, what's the behavior, how many of these flows are to your internal data center servers versus what's going on in the public cloud.
That IoT traffic chart, is that like a connection?
This is an aggregation.
No, the big pink one, the big pink.
Oh, this one, yeah. So this is the new stuff.
On what?
Yeah, this is a busy slide right now because it's a cumulative flow. When you start to drill down and filter it, it starts to only show one of those.
Talking to who?
That is right, yeah. So it just keeps you telling you all the flows. When you aggregate it, it looks literally like a spectrum band. But the good thing is you can explore. So you can go inside, you can do slicing and dicing. For example, okay, now I know what my network is, what my VLAN is, what my postures are, but then I can do, slice. I can say, okay, I want to filter all the machine learned IoT clients. Inside that, let me take something like computer servers. I click on this. Now I'm looking at I have only 3 clients that are machine tagged, but also that are classified as computers or servers. And then this becomes very manageable. Then you're looking at, okay, you know that all of these guys are using only that one network. This is one SSID, AnyCorp SSID, this typical behavior. It's Windows, we know that because we filtered on it. And then it tells you very specific destinations that it's trying to reach. So we give you those kind of details. These are something that a lot of our system administrators have been asking for a long, long time, to slice and dice the data, show what's going on per client, a set of clients, look at the behavior and see what they're trying to do. So this is fundamental to how we start looking at our NDR assessment. So this is like you're looking at behavior, looking at baselining on those behavior, and then start to figure out what could be a possible threat scores. And then also, it's another important thing that shows up, which you will see tomorrow, is it can do a few interesting things. You know what are anomalous flows, but you also know what are regular flows. Most of those IoT flows are fairly, very well defined. So with things like these, for example, we can now give you a policy optimization construct where we know how many flows were there here. It gives you what kind of creations you can do, and you can click on this. It actually exposes some of those charts that you asked. We can actually show you, offer a recommended policy saying this is what you could do for this particular client. So this becomes more like an allow list in your firewalls. So we're now going and looking at those. So this is one of the most complex things. When we ask most of our customers, how do they configure the firewall rules? It's a fun stuff. That's a fun conversation because it's been traditional IP ACLs, go source destination, and then nobody touches the firewalls. Nobody wants to remove the rules. So the rules keep expanding because they don't want to delete it. Nobody knows what's going to break. So the first step we did was in Aruba, we made it more like a role-based rules. But the second step is we are also now taking it to the next level. We're trying to show you, hey, we know these flows are more sanitized because we think it's very predictive. This is common baseline. They are safe. Create rules like these, and you'll be good. Because you can always have a any deny at the end, but you can start to build your allow list in the front. So this is a very powerful tool to take this to the next step. This is one of the things that you will see that's coming up in IoT classification. Yes.
Do you do any like correlation with like geo IP stuff? So looking at where the flows are going to, and if there's any destinations which are, considered unsafe, you then
Yes.
end up blocking those. Or
I wanted to hold that back for tomorrow morning, but we do look at destinations. We look at outside the country flows. Those are the most common flows that we see for security vulnerabilities. So yes, I have it in the slide, but I wanted to keep that for tomorrow morning. So my presenter there has something new to show to you. But please do visit there. Tomorrow is really fun day for us. We have a lot of exciting stuff lined up for you. So, but this is some of the things you see. The other thing that you'd notice is client connectivity experience. Now, this is where we're plotting. We are building an aggregate view where we're trying to show you what is the client connection time. We're kind of correlating flows. We're looking at latencies, but we're also using machine learning to kind of tell you what are the flows, how does it look like on an aggregate basis for a given WLAN. So in this case, for example, we're measuring DHCP latencies and auth latencies and kind of giving you baselines of which is acceptable within the limits, which is working good, and which are the ones which are like not performing so good. So we kind of give you that score as well. So right now we have only the aggregate charts. Jose will actually cover more details. In the next sprint, we probably are going to double click on this and we can open up the details of what that is there. But this is because my live system, I'm just trying to show you what's there. But this is some of the things that I had to show you. I covered application performance, I covered client experiences. Now I'm going to touch on something what we actually built something recently. We've had AI search in Central for many years now. We had the first generation AI search that was running on Watson's capabilities, but we recently pivoted to a generative AI based search. So this is, again, another thing that you're going to see tomorrow morning, some exciting stuff that we're building up. But what I'm going to show you is things where our graph database, again, comes very powerful. When you're trying to correlate between states, which are dynamic, changing seconds by second, and you want to kind of look at this data, one of the expressions that we could use is use an AI search. So for example, we're looking at failed clients. I'm just going to give a search at the top level. Maybe I should have done it in the top level. I'm doing it in a site. It kind of gives you a health score. This search actually looks at all of the sites, all of these devices. In this case, I'm actually filtered on one site. I can do this search on the global also. So I can go across all of these sites and notice it's looking at health scores. Now, these health scores are dynamic. These health scores change every 30 seconds in our network on the reds. Yes, sorry.
Question, since it's you said that it was like AI based, can you put in like failed clients and like IoT?
Yeah. I could
so
do
that it can,
something like
give you a
Windows
smarter response.
failed, or Windows, just failed something. I can do, part search. I'm trying to be brave. I don't know where I'm going to end up with. Okay, so I failed it. Yeah, so Windows. So I just kind of slice it down. So what it does is it's basically looking at the classification data, it's looking at the health data, and it's also looking at the experience data, and it's searching across all of these data and bringing all them together. This is the power of graphs. We are the only one in the industry right now that has this. This is very, very powerful. Of course, there are predecessors in other industries like Facebook, very, very well popular graph users, like they build their entire system on that. We realize that this is the way to go forward. This is path breaking in the network management space. So this is one example of what we showed you. You can do slice and dice and a lot of these globals. We also show you something which is more like, I want to kind of show you something more generic. We also do, like, for example, you can do this search even in global level. So this is big because when you do search across databases that are spread for a very, very large data set, think of a big enterprise, large universities in US, 120,000 clients, 30, 40, 50,000 devices. It can be nasty queries. This works very well, and we correlate this very well. And I'm just trying to see if I can show you, video devices. I'm just going to I don't know, I'm just giving flat. So there are two things that we do. We not only look at the config database and the monitoring database, but we also do curated documentation. And this is one of the things that we realized is we want the search to be a good assistant to the user. So we actually curate that, and for them, if they're looking at something, we can pick some of the sections in the document that actually can help give context to the user and when they want to do it. So we actually search those and actually get those in from the document as well. So this is how the large language models are really, really useful. It kind of look at massive amount of data, and I'll leave it to Jose later if I want to kind of give him some time. So this is something really, really interesting that we are very, very thrilled about. I want to kind of switch gears, go a little faster now. I want to kind of share something about the alerts. So we have a whole bunch of alerts. Okay, this is the fun stuff in live demos. And I did something wrong, and I got stuck. So I'm going to take the alerts. Now, we've built a whole bunch of alerts that are done on the fly. This is one of the biggest improvements that we've done from the Classic Central, where we are now using machine learning and AI to kind of crank at all these events and look at what could be possible alerts. This works real time. From the start of an event, we can actually flag this in less than 4 minutes. That's our capabilities that we can actually bring in. Things like we get into root cause analysis. For example, I'm just going to click this. This is a WPA client. It tells you it's a 4-way handshake that failed. We also give you some amount of information like what SSID it was working on, what are the incorrect SSIDs, where we give you recommendations. So we're trying to give you a little bit of a blast radius of that alert, saying how many clients are impacted by that. This is not much. There's like just one client. Maybe I should pick something else. I'm just trying to see if maybe this might have more. Oh yeah, so this is a DNS response. I'm looking at DNS response services. Now here, this is it failed to get DNS response. So there are things that are more important questions that most administrators ask. Okay, I got this, but what do I do next? So we are trying to bring in all the impacted VLANs, impacted SSIDs, and we're trying to bring all of those in one place. We also give the blast radius as the clients. You can click on the clients. We take you to those clients that are impacted. Now notice the clients might be in different state of health. The alert is somewhere else. So alerts are like more capulated, but dynamically the health is recomputed. So these are things that we actually try to give you kind of slicing and dicing of data. I kind of touch based on the alerts. Now I want to go really fast on show you some of the other insights that we have. I want to kind of show you something on the performances, like what can we do as improving performances in the network. This is one of the things that we have actually got in this product is we noticed that there are customers who have 2.4 and 5, but they actually a lot of times don't turn on 6 in some, or there's capabilities there. So you hover around this and oops, and you can see this. We are actually recommending to turn on this for a specific channel that we're looking at. So you can go turn on this channel for this. Sometimes the distribution is more calculated based on what would be the most optimal performance improvements. And Jose will go more in details about the under the hood, what's the secret sauce of how we come at it. But we estimate this would be the gain in performance for the network by doing this.
At this point where the administrator is seeing this message of recommendation, how many steps do they need to take in order to accept that? Yeah, you're smiling. The recommendation.
How many steps?
Yeah,
I just clicked.
Just be like, just do it. Or do you have to like drill in and click and like do the?
This was like 3 clicks to get here.
Okay.
And when I
saw that.
Yeah, and
But sometimes enabling the recommendation is.
Oh, so these recommendations are fired by themselves. They just like by default fired. Yes. Yes.
I'm interested in how the recommendation is determined because it's it feels like it's done on throughput, reading the information there.
Okay.
And it's going use a wider channel, 160 megahertz wide channel, which we normally would never do because of co-channel contention and other factors.
Perfect. This is the time where I have 18 minutes to go, and I'll have Jose open the hood and show you the internals of the stuff now.
So as you know, in 5 gigahertz, there's lots of APs and there's a lot of clients, so it's pretty code channel limited. So if you have 50 APs in open space, they'll go to 20 or 40. But 6 gigahertz right now is the Wild West. There's very few clients. It's the channel utilization sitting at 1%. So you could get big lots. Our model, what it does is, given you 5 gigahertz propagation and co-channel and stuff, it predicts your 6 gigahertz capacity. And given how underutilized 6 gigahertz, right now 160 is pretty much the best. Over time, we'll start cutting it down. But the model predicted that. That was not made up.
Does it correlate the number of clients that are 6
Yeah, of course. Yeah, of course. Which,
moving them off 5 gigahertz would
Yes.
free up more spectrum.
yes. Right now, about 5% of the clients are 6 gigahertz capable. 5%. We have a database of 1.5 billion. About 5% of them are capable. And as Seelan said, because a lot of people inheriting config from the older APs, they have not enabled the 6 gigahertz. So there's one click away from turning it on. But most people, they just buy new APs and they forget to open up the AP group and click on the 6 gigahertz. So I could tell you 85% of our customers that bought AP 600s have forgotten to click on that button. So 85% have 6 gigahertz turned off. Only 5% of clients are capable. That's why 160 is the best right now.
I think
But over time, the optimal will be lower.
there's not many clients, but you've still potentially got the same number of APs, and if you're going to turn on 6 gigahertz on every AP,
Yeah.
then you're still potentially going to create a code channel.
Yeah, but if there's only like 10 clients in a whole site, and 6 gigahertz has like twice the bandwidth of 5 gigahertz,
You won't find it.
there's plenty of 160 gigahertz channels to go around for the 10 clients. So each one could get a whole superhighway. There's no need for them to get into these narrow band things and have one channel each. They could all get the superhighway. But over time, by the way, this thing infers daily. So every day we re-infer it. So if we figured out there's too many clients, we'll drop it to 80, we'll drop it to 40, we'll drop it to 20. I don't think it'll ever have to drop to 40, actually. There's a lot of real estate out there. But in any case, let me go to the actual presentation I was going to try to go. I'm going to go very fast. So as Elon said, the baseline for everything we do is knowing the class of the clients, right? Because if we're going to optimize for performance, we need to know what the clients. If we're going to figure out baselines, we have to figure out what the clients. If we're going to find policy things, we know what the clients is. So the first thing we do, identify every client. So within millisecond, okay, go ahead.
How do you handle, if you're using MAC addresses to start, how do you handle MAC address rotation?
Yeah, exactly. So that's the list of all the features we could possibly use. 70% of the clients are randomized MAC right now. 70%. So for the 30% that are not, it's a key feature. For the 70% that are not, it's not a key feature. So when you have a machine learning model, you get 15 features, some are NAs, some are not. So yeah, so the list of features we use includes MAC vendor, it uses DCP option, it uses user agent, it uses behavior, app flows, Wi-Fi attributes, as on the guest network, it's in the 1X, it's a WPA2, it's WPA3, all those are features. It goes into a 15-dimensional model, and it says, this is an iPhone 15. That's what it does. And of course, iPhone 15 is randomized max. But there's plenty of actually, if you look at the client distribution, there's like the top 10 are like 90% of the clients. And it's this very, very long tail. The long tail didn't randomize max. The 10, 15 most popular clients, of course they do. And they have the most of the mass. In any case, that's the list of features. But in any case, some examples of models we use is this MAC address classifier based on Gaussian density. That only applies to the 30% that do not randomize MAC. That model does not run on the randomized MACs. Then we have the IoT tag random forest classifier that Seelan talked about. So if we have a client to figure out that it's boring, it's kind of doing similar things, it's not moving and stuff, so we know we tag it as an IoT. Some metrics on the models. Of course, we have a bunch of heuristic learn rules about client features to client class. And in total, we have over 99% coverage on data active clients. The reason I put data active is because in a lot of our wireless environments, clients will just walk by a parking lot, connect for 1 minute, they don't even DHCP. We have no features. It's a random MAC, it spent 1 minute, it passed one packet and didn't DHCP. We have no information. So we're like, no clue.
We don't care.
Exactly, we don't care. So I could tell you that 5% of our clients walk in front of our buildings, in front of auto APs. We have no features, and it's NA. But if they actually get on your network, they DCP, and they pass a few flows, with 99% of the time we know what it is. And that's the beginning for baselining apps, baselining behaviors, optimizing 6 gigahertz, and knowing that 5% of them are capable. So, of course, we're missing the 1%. Where's the missing 1%? Of course, there's new clients constantly being added. So what we do is we have this weekly job that goes after the 1% of unclassified data active clients, and we cluster them and figure out into groups and what features makes them common so we can label new client devices that are showing up in the environment constantly. So what do we use this? So as Silan was saying earlier, if we want to figure out what the cameras are doing in your site, first we classify them, then we figure out the aggregate of the flows that the cameras are doing across all of McDonald's, and then we figure out if one camera is different. So we figure out the baseline of what's normal for client type camera, and then figure out the one that's doing something different. So we use that a lot. Of course, another thing that came up was applications performance. So sometimes the application is poor in a specific client type, but we do baselines across the aggregate of client types, and then because we have traceroute, because we have a data lake that has all our customers in one place, we could figure out if the customer has a bad ISP, or if the application is actually slow in that country, and all that stuff is done by isolation forest algorithm. So basically we get everybody in our US clusters, and we have about 1 million APs in there. And we figure out who has, in which zip code has a slow application behavior, or which customer has a slow application fit. So we could actually segment it between, is it the WAN, the LAN, or the application? Because we have all this data. In any case, all these things run weekly and infer daily. So because I have 11 minutes, Silan kind of talked about this. Okay, so as we know, well, I know, 99% of the time, DCP, DNS, SOC works. But once in a while, you hit a roadblock. So the key is how fast, and Silan talked about how fast can we actually tell you that you are off the baseline. And this is where Silan talked a little bit earlier, within 4 minutes, we could take raw events being generated at the devices and figure out what happened. And the steps are ingesting more telemetry that gets sent to central within seconds of the device detecting it. We have a targeted baseline for that type of environment. For example, outdoor APs, roaming is much worse, SNR is much worse, retries is much worse. So we don't want to trigger a high retry anomaly on an outdoor AP when the SNR is like 7 dBs or 8 dBs. So we have to baseline your environment. Is it indoor computers, or is it phones and outdoor service provider? So that's a baseline. Then we trigger what's anomalous for that environment, for that client class. Is it a phone, a printer, what it is? Then we actually cluster those. And so these things don't show up as being too repetitive. We run lineages algorithm against. So if some problem is new, it'll be a new alert that we cluster, and we'll actually go and flag it and tell you what's going wrong. But if a problem is ongoing, instead of showing you over and over and over again, actually Silan shows some examples. Some of those WPA3 synthetic failures he has in the lab, it's been failing for like a week. And it's showing you, instead of showing you 1,000 failures, we show you one. He didn't have time to show, but it tells you when it started and if it's ongoing right now or not. So the lineage actually connects across time for the same problem, across topology. We've seen issues where like an AP connectivity issue is really a gateway tunnel flapping issue. So we have to correlate not only the events across time, we also have to correlate across the network. And then what happens is we have, and I think actually it was a different meeting, we have this lineage of anomalous clustered problems, and now we have to root cause it. So it turns out the more powerful LLMs out there have ingested all our troubleshooting guides, all of our competitors' troubleshooting guides. And if you say, I have this and this and this, what should I do next? LLMs are able to suggest 2 or 3 things. We could also ask the LLM, we're seeing the symptoms. Is this enough to troubleshoot the problem? Say, nope, give me more information. So what we do is we have these flows where we go to the device and ask for more information. It's listed under here of APIs to the device. I listed as CNX. So from CNX, if we find a problem and we don't have enough information to troubleshoot it, we'll go to the switch, we'll go to the gateway, we'll go to the AP and ask for additional information. In addition to all this, because we have a data lake of 4 million devices, 1 billion things, sometimes what ends up happening is we find a specific client type, a Raspberry Pi, a print or something that's very slow at DHCPing or something. And instead of flagging your DHCP server sucks, we go look in our database if that printer type has had issues in the past with other customers, so we don't flag you. And this is actually a real thing. There's actually some older devices, 10 or 15 years old, that are kind of semi-interoperable, timing out. It's not a problem with the DHCP server. It's actually a client's fault. So we have this database of interoperability issues where we store all the client types that have issues. So that is all I could say in 3 minutes. Okay, so what I talked about before is your network is working okay, and all of a sudden you hit a problem. a DSCP server went down, a DNS thing, an application server is failing, or your ISP is down. But this is more about, are you running the fastest you can, right? So you have your network and you forgot to click the 6 gigahertz box, which is there in central, but they didn't click it. So this is about, are you using your network at full capacity? Obviously in this picture, there's 3 lanes. I know it's they're not supposed to use the other lane, but are they using all the full lanes? And this thing is for the 6 gigahertz really. So some observations about what our customers are. Because we have over 100,000 customers, we have their configs. I could tell you that our customers, most of them, they inherit the default configs and don't change anything. Whatever came out of the box, that's what it runs with. So, because a lot of people buy AP600s and they used to have 500s, they're running with 6 gigahertz off. Only 15% are running with 6 gigahertz on. 15% of our customers have had an interoperability issue with 11AX and they've disabled it. And that problem could have happened 2 years ago, and that client is no longer there, but they're not gonna check if I enable again, is it gonna work? They're not gonna take that risk. WPA3 is a security standard that has been around for like 3-4 years. The people have had WPA2, they're comfortable with it, they don't wanna take the risk that if you turn on WPA3, some of the clients won't connect. So only 15% have turned on WPA3. And then have a list of other configs, like 11R is turned off like 90% of the time, and all this other stuff. So another thing, people are very reluctant to upgrade their code. So they're running very old code. I mean, you put on your campus network, you put on your code, it works, don't touch it. So I can tell you the average customer runs code that's 2 years old. So we have put in all the recommenders to deal with all the things that I talked about here. We have recommenders for everything. So what do the models usually do? They do 2 things. One is they train across all customers. So they figure out for the clients in your customer, the APs that you have there, the switches or the gateways that you have there, what would happen if you switch each knob and it predicts the performance? So for example, if you turn on 6 gigahertz, given all our customers have 6 gigahertz on, we could figure out what happens with on and off. We could do that model. And we could do that for 6 gigahertz, 11EX, firmware, WPA3, anything. At the same time, because Wi-Fi has been around for 20-something years, and there's clients that are 20 years old sharing the same spectrum as clients that are just generating today, and there's like 5 or 6 different standards all sharing the same medium, there's interoperability issues. So customers are often afraid to turn on the latest knob because they may have a client that's 10 years old and may not work. So we do that. So our models do 2 things. One is figure out of the 1.5 billion clients, we put them into types. We figure out all the knobs, and we figure out, are they capable or not capable of 11AX? Are they capable or not capable of 6 gigahertz? Are they capable or not capable of WPA3? And also, if you turn on that knob, will that client not connect? If you turn on 11, we actually have on some clients, actually modern clients, that if you turn on 11R, they hang. So we have the list of clients that have capable of 11R, may hang with 11R. Capable of 11X may hang up with 11X. And we have all this database of gain and pain. The gain is how much you gain for turning on the model, and the pain is which list of clients in your site may have an issue, and it's person's ID. So what ends up happening is we'll do a recommendation, and Sealand showed us a few, says, okay, turn on 11AX. It's person's ID. We study your site for a week, and based on all the other customers, we figure out how we'll do for you. And the recommenders we have right now is, this is the list, and actually I did this slide 2 or 3 weeks ago. We've added 2 or 3 since. We actually, obviously cloud-based, we're actually adding 2 or 3 new insights a month. This is the list for May. In June, we have 2 or 3 more. But there's the list. And usually what these things do is, Sealand walked you through a live demo, and it shows you on the left all the ones that apply to you. And they're one button away from just applying. It's basically just, 11AX is a button, 6 gigahertz is a button, WPA3 is a drop down and a click. And from recommenders, a download and a click. So most of them are like 1 button, 2 buttons away.
So I just want to make sure I understand what you said correctly. So these recommendations, let's say it was enable, 6 gigahertz or enable later to 11x or something. Is that based upon looking at other sites that already have that turned on? Did you say? Of a customer?
Can you say that question?
Is it based upon looking at other data of a customers that already have that feature enabled and how their clients are performing? And do you look at typical environments? So like, it's a similar environment, as in it's an education environment or it's a warehouse?
So the environments get featureized. We do not have labels saying this is a high school, this is a hospital, this is a hotel. We do not have that feature because our sites, people don't go into Central say, this is a hospital, this is a site. But we featureize it with things that affect 6 gigahertz. Like you were saying earlier, Channel utilization is a feature. AP to AP path loss is a feature. Number of APs is a feature. AP bottles is a feature. The number of antennas in AP is a feature. The number of antennas on the clients is a feature. The number of clients, the applications, the client type. Is it computers, laptops, IoTs? All those are featureizing the environment. So what is special about a dorm? It probably has a decent amount of computers, gaming devices, and phones, right? Mostly iPhones in the US. What is common about an office space? Probably laptops and phones and some printers, right? So we're featureizing the environment and then the AP density. The AP density in offices and dorms is very high. So instead of labeling it dorm, labeling it office, labeling it Home Depot, the features speak for it, right? So the same way people talk about LLMs now, it's all about embedding sentences. So they get a sentence and they convert it into a vector. Right? They're not really getting the words in a sentence, they're just getting the vector that explains that thing. So we have vectors that explain sites. So we train it on every customer's data, and then we go one by one, checking, do they have the optimal configs?
And then, so in terms of the optimal configs, then is that ultimately, you've said, well, we've seen other environments where client performance has been improved.
Yes, of course.
By turning this on. Are you actually looking at client performance?
Of course.
Looking at?
Oh, yeah. So those bar charts, so you say, this is the peers of yours, the performance that the clients were getting before, and this is the clients after. So I cannot even read that font. That's just a screenshot. So that's probably the 6 gigahertz one. So that's the bar height, and I cannot read it because this was just a screenshot to show some. The bar heights, the dark blue is the before, and the green is the after. The AI model predicts, based on your clients, based on your AP density, based on your SNR, based on your channel utilization, that you'll go from the blue to the green. So, oh yeah, exactly. Yeah, it could be it. So yes, so this is a customer that had 5 gigahertz on, and if they turn on 6, their speed will go to the thing. This is the client speed, by the way. The y-axis is the client speed, and the bar height is how fast they could go. And this model was trained on all the other people that 6 gigahertz on. The 15% is helping predict the performance of the 85% that turned it off.
And when you're talking about transmission rate, sorry, are you talking about like throughput or data rate of the
throughputs of data rates? Yes.
Which then?
The MCS of the phi.
So you're looking at the MCS rate. So you're saying you can get a higher MCS?
Yes. It's the MCS of the phi.
Okay.
Yes. So you could get from whatever, 200 to 500 or something. I can't really.
And that's what I was interested in.
Yes.
Because obviously, just improving MCS rate, you can do that with wider channels. There's lots of ways.
Yeah. No, by the way, this is both.
It doesn't always increase performance because sometimes.
This is actually saying that you have 40 at 5, and it becomes, and we recommend 160 at 6.
Yeah, I guess my thing is it purely improving MCS rate. I don't think it's always.
No, it's net MCS rate after throwing in retries. It's the net throughput you could get if you're doing a speed test to a client.
What if we ask a little differently?
Right, okay.
Based on your suggestions, do you have a data point?
Oh, of course.
To how many recommendations actually yield better results?
Yes.
How accurate is it? So how accurate is it?
Within 5%.
So 95% of the recommendations made generate beneficial results, or it's getting.
No, 100% of them give beneficials because they're 5% error. So that green bar could have a 5% error on the height, but even with 5% error, it's higher than the blue. So if it's 100%, I mean, so you have a level, and you're trying to predict this level, and this level has a 5% error. It's still always better than this one, as long as you make sure this thing is like 20% better than this. So our recommendations, they do two things. One is, what is the error in the estimate, and make sure the worst case is still better than what before.
And so then following the change, the data is showing that through.
Yes, of course. Yes. Because we only would make the recommendation if we're very damn sure. Why would we do it otherwise, right? I mean, these are the slam dunks. A lot of these things are slam dunks, right? Turning on 6 gigahertz. I mean,
I guess my question was some of the things you've got there increase your actual data rate you can operate at, but they also increase overhead on the medium. So depending on the number of clients.
So 6 gigahertz is free spectrum.
Always want a higher data rate sometimes for.
Well, it's retry corrected, of course.
Okay.
So if you have to retry the packet a lot, then you have to, you have to subtract the retries, of course. Yes. But turning on 6 gigahertz is a slam dunk. The model's predicting how much you're going to get out of it. Turning on 11AX is almost always a slam dunk unless the clients are not capable, in which case it's just adding overhead with no gain. So we obviously know the client capabilities I was just talking about earlier. We know exactly which clients in your SIDs are capable, not capable. So if a customer doesn't have any 11AX capable clients, we're not going to recommend to turn it on. It just adds overhead.
Would you recommend turning it off?
We don't recommend turning things off. But yes, if you have an SSID and it's all IoTs that are 11ACs, they should turn off 11AX and get like 5-10% off.
That's what I'd like to see, sometimes recommended to turn things off.
So we could, I mean, that's not hard to do because we have the model that says if you go from A to B, you gain how much. Obviously, that model could be used in backward mode. If you go from here to here, how much you lose. So it's the same model. The model, the only thing it does is based on your clients, based on your environment, what happens when you flip the button. You can flip it this way, you can flip it that way. So, but yes, it wouldn't be hard to do the turn it off button.
Like,
Especially if you haven't, that's easy to do. Yeah, we could do it. It'll take less than a month.
So with that table or any of these tables, if I see sort of that insight that I'm going to make this change, I
Yes.
see that. When I make the change, do I get to see comparatively against where I was?
So that's a workflow we're going to be adding.
Okay.
Right now, I actually screenshotted two things. The gains, in the bottom has a pane. It tells you which client doesn't support it in the bottom. But we do not have a workflow that if you say yes, it triggers a before and after and shows you the gain. We do not have, obviously we have all the data,
Right.
It's just not showing this as a report.
Okay.
So what we're missing is generate a report of what happened a week later. These models are usually based on 1 week worth of training inferred daily. We just have to wait a week and tell you how much you gained.
Yeah. I think that'd be cool to see.
That'd be cool. I agree.
Maybe I misunderstood when I asked the question. If you said within 5%, all the changes you're suggesting take place, and if they're within 95%, you wouldn't need a graph to verify it.
No, but
95%.
But if we predict you're going to get 100% improvement with plus minus 5% error, it could be 93, it could be 107, right?
But like
You may want to know, did I get 93 or did I get 102% improvement?
It's more about verifying.
Verifying and feeling good about yourself. I mean, right? I mean, just say I applied the button. I want to know how much I got out of it. It's fair.
Yeah, and I mean,
We were planning to do that, but
your environment could be like a statistical.
if you have, yes, our models, even the worst case, maybe there's some strange environment we've never seen in our training data, breaks.
Yeah.
We haven't seen it, but it could happen.
Or to report to your boss that you weren't taking a big risk.
Yeah.
I did this, I recommended it, and here's the result.
Yes. So in any case, I'm pretty sure I ran out of time. Yes, I'm in negative territory. I'm in negative territory. This is the block diagram of the LLM-powered AI search 1.0, but the one they're going to show tomorrow is 2.0. So I could show this one because this is the one that's going to be outdated. And talking about what Silan had earlier, there's a bunch of, instead of having one big monster LLM that does everything under the sun, because a lot of things are going after intent. You saw his response time. It's like 100 millisecond response time. So we're not going for quick things, intents. We use small targeted trained models that we trained. And for big document search, we use the big models. So what is happening here, there's an ensemble of models. The bottom thing has the real big LLM. Everything else on the top, figuring out the NER entities, figuring out intents, auto completions, all that stuff is small models that are very quick. So you get quick experience and good outcomes. So
is there a block that integrates humans feeding back into the learning algorithm based on support tickets that are opened to kind of teach and enhance that? Or is it all just based on the data points it can collect from logs and knowledge articles?
So this one, as you see this obviously version 1.0, we launched in March or April. It's based on data only, no tag cases. But we're working on the one you just said, throwing in tag cases in here. Yes, of course.